In this one, let's take a look at graphing an absolute value. So imagine this one right here. That looks like this. Say 2x plus 1 with an absolute value bars. So I'm going to apply the definition. The definition of absolute values is the following, that you put down this big brace, and then remember over here, let's review the basic absolute value before we get to this one. So then this one will be more meaningful in case it's been a while for you. Absolute value in its basics, by definition, is this one. When you're graphing more complex versions, the basic definition turns out to be very useful. Remember, the definition says it's x, and then this is when x is greater than or equal to 0, and the negative x when x is less than 0, like that. So that's the piecewise definition of absolute value. We can use this when you're graphing something like, say, 2x plus 1, so that it becomes a very mechanical and reliable process. So what I mean by that is, wherever you see x in the definition, since here between the bars I'm putting 2x plus 1, here after the brace also everywhere you see x, put 2x plus 1, like this. 2x plus 1, and also in the inequality where it says x greater than or equal to 0, put 2x plus 1 greater than or equal to 0. We'll get to that in a second. Then again, on the bottom where you see negative x, you put negative. Make sure parentheses, and then you put 2x plus 1. Like that. And then after that, you put the following here. Instead of putting x, you put 2x plus 1 is less than 0. That's it. Then you just basically make a small adjustment here, which is you keep this piece, it's 2x plus 1. If you want, you can distribute the negative over the parentheses, so it becomes negative 2x minus 1. You can solve this 2x plus 1 greater than or equal to 0 inequality over here to get x by itself. So if you do this, for example, this will be, let's see, over here. I'll do that on the side. So I'm solving 2x plus 1, that inequality. So it's 2x plus 1 greater than or equal to 0 minus 1. That gives 2x greater than or equal to negative 1. Then you divide it by 2. So x is greater than or equal to negative 1/2. So that means over here now, in this position, you put x is greater than or equal to negative 1/2. I'm showing you this process because it doesn't matter what you're graphing, what you're plugging in here. You just make replacements of everywhere you see x with the expression, then you simplify a little bit. It generates this piecewise defined function, and then you can graph like a robot. It's mechanical and reliable. Then for the same one, I got to do this on the bottom now. Take a look. So I'm going to say 2x plus 1 less than 0. I'm taking this inequality, 2x plus 1 less than 0. I'm solving it for x. So it gives 2x is less than negative 1. I subtract 1, then divide by 2, divide by 2. So x is less than negative 1/2. So over here, I put x is less than negative 1/2. Now you've got the two major pieces that define the inequality right here. That's it. No guessing, right? It's all mechanical. So once that is in place, the rest of it depends on how much you know about graphing. For example, a piecewise defined function. So here, as an example, take a look. I'm going to make a small sketch. It doesn't have to be perfect. It'll get the idea across. So this is x and this is y. It looks like that. So now you look at the first piece. When x is greater than or equal to negative 1/2, you use this piece, 2x plus 1, to graph. So for example, let's say this is negative 1/2 in this position, okay? First of all, it's greater than or equal to it. Therefore, here, I'm going to take this value of negative 1/2. And what you can do is plug it in here, okay? To get the first y coordinate. Remember that the value of this expression, these are just your y coordinates, that's all, okay? So when I evaluate the function here in this form at negative 1/2, let me do that over here, okay? I need to move over to a different position. So I'm plugging x equals negative 1/2, which means this is the portion that is used, the upper portion here, because x equal to negative 1/2 is made true when you plug it in here, right? Negative 1/2 is greater than or equal to negative 1/2. So you know you got to use this piece, not the bottom piece. So that's going to give me 2 times negative 1/2 plus 1. You cancel off the 2's. And that basically is going to generate a y coordinate for you. So that y coordinate will be equal to the following. Let's see. This cancels with that. So then you have negative 1 plus 1, negative 1 plus 1, which is 0, just the way you see it. So I'm at this point right here. Okay, this is the point, -1/2, comma 0. Let's do one more of these. So this time I'm going to choose x equals 0. Again, when it's time to decide which piece of this to use, so it's mechanical and reliable, you just plug this value into this position and you check it. Like this. It's as if you were doing this right here. Look. Is 0 greater than or equal to -1/2? That is true. That's important because that tells you that 2x plus 1 is the right piece to use. Alright. So I'm going to put the x back though. Let's go through that process. When x has the value 0, you're going to end up with 2 times 0 plus 1, which is just 1. Like that. So then I mark this over here at 1. So this was -1/2. Maybe 1 is somewhere over here. And then you can easily imagine that it extends forever pretty much in that direction. How do I know that? Because it's a linear function. It's 2x plus 1. That's a linear function. It gets a straight line. And that is the piece to be used when x is greater than or equal to -1/2. At the next stage, if you want to be really careful to get this just right, what you do is you repeat this, but this time, for example, use values to the left of -1/2. So in other words, you're going to use the bottom of the symbol right here, okay? The bottom of the brace, this portion. So for example, like if you let x have some value like, well, this is -1/2. Imagine you stick in -1. That means you plug it in here. It's as if you were literally doing this and you say, is this inequality true? Is -1 less than or equal to -1/2? The answer is true. That tells you, because this is true, that this is the correct piece to use. All right. In general, though, we just put x. We don't write specific numbers in there, but that's what you should be thinking, really. So I know when x has the value -1/2, you got to use the bottom brace here, the bottom portion of the brace. I'm going to put -2 times -1 minus 1. Let's work this out. So -2 times -1 is +2. +2 minus 1 is +1. So I know when 1 goes in, when 1 negative goes in, this is -1/2. So let's say that's about over here, -1. When that goes in, +1 comes out as the value of the function. You see, like that? And then you can easily imagine doing this, the other way. You basically end up with a curve that looks like this, a V. So this is a way of doing it. Some people don't like this way, some people do. I personally, at least I'm showing you this way for one simple reason, that it's mechanical. As long as you understand how to begin with this. This was step 1, right? This was the basic definition of absolute value. Then anything that you plug into this position in x, make sure you also stick it into this position, this position, this position, this position. Make all the appropriate adjustments the way I did. Again, remember, so in my case, I began with the basic definition, say this was step 2. Then in step 3 here, I adjusted all of this to get step 4 down below, right here. And then after that, I knew exactly that this piece was the one to be used when x was greater than or equal to -1/2. This was the piece to be used when x was less than -1/2, and that's it. If you learn it that way, then it becomes mechanical. No guessing is involved, which is nice. And maybe this sequence of steps was roughly like step number 5, okay? Alright, thanks so much for watching. I'll see you in another video. Leave a like.